In this series of courses, we will cover everything about pulse jet bag filter. This course will explain Bagahouse operation problems, failure patterns. Course 4. A glossary of terms related to bag houses and fabric filters. Abrasion bag failures, flex and surface. 1. Flex failure. Caused by excessive movement, from under-tensioned, or over-cleaned bags. 2. Surface failure. Caused by high particulate velocity impacting, or sand blasting of the bag, or friction rubbing from another source. 3. Hopper baffle. A device located in the bag house hopper, that helps evenly distribute the air and dust flow into the bags. It may also function to knock out big particles. 4. Bleed through. Dust penetration through fabric filter bags. 5. Blinding. The flow restriction that occurs in fabric filter bags, when dust becomes lodged in the media, causing high differential pressure, a condition that eventually occurs over time. 6. Premature blinding. A flow restriction to fabric filter bags, typically a result of improper new bag startup, or overcleaning, that requires earlier replacement than expected. 7. Blowpipe. A pipe or manifold used in a pulse jet bag house, to direct air jets into the tops of the bags for cleaning. 8. Cage. A wire structure used to support fabric filter bags in a pulse jet bag house. 9. Cell plate, tube sheet. The internal divider surface that separates sturdy from clean gas plenums. Fabric filter bags are seated in the cell plate. 10. Compartment. A segmented filtering section of a bag house that can be isolated from others. 11. Clean on demand. The process of cleaning the bags, based on differential pressure as opposed to a timer. 12. Can velocity. The air velocity between the fabric filter bags of a pulse jet bag house as measured at the bottom cross-sectional area of the bags. 13. Denier. Size of the yarn per weight unit length, used in fabric filter cloth. 14. Dew point. The threshold temperature at which condensable start to turn to a liquid state in a bag house. 15. Diaphragm valve. A fast-acting valve, used in a pulse jet bag house to release air from the storage tank into the cleaning blowpipes. 16. Differential pressure, delta P, pressure drop. The resistance to flow across, or through, a bag house, measured in inches of water column, in inches H2O. 17. Dust cake filter drag. The resistance to flow delta P caused by dust accumulation on the bags, in inches H2O. 18. Fabric filter. A term typically used in the utility industry, when referring to a bag house. 19. Filter media. The type of cloth used in fabric filter bags. 20. Impingement. The act of particulate striking and attaching to fabric filter bags. 21. Inside collection. The collection of dust on the interior side of the bag, as in a reverse air collector. 22. Interstices. The open voids in the cloth of fabric filter bags, where air passes through. 23. Life cycle. The length of time a bag is in service. 24. Magna-Helic gauge. A device used to measure differential pressure in inches H2O. 25. Manometer. A water-filled, U-style gauge, used to measure differential pressure. 26. Mullen burst test. An ASTM rupture test, for measuring the strength of filter bag material, PSI square, inch of material. 27. Null period, settle time. A time segment during offline cleaning, when filter bags are allowed to rest, without any cleaning energy applied. This allows the displaced dust to fall off the bags and settle below the inlet opening. 28. Outside collection. The collection of dust on the exterior surface of the filter bag, as in a pulse jet collector. 29. Permeability. The measurement of airflow, in cubic feet per minute through 1 square foot, of filter bag area at 0.5 HO, delta P. 30. Plenum. The baghouse housing area above, or below the tube sheet, either dirty or clean. 31. Poppet valve. An efficient sealing valve used on the outlet side of a baghouse to isolate the gas flow. 32. Pressure drop, delta P. The resistance to flow across, or through, a baghouse measured in inches of water column, in inches H2O. 33. Precoat. A protective artificial coating, added to the filtering surface of bags, to aid in startup and or collection efficiency. 34. Pulse duration. The time a diaphragm valve is opened during the cleaning of a pulse jet bag house. 35. Solenoid valve. An electromagnetic pilot valve, used to activate a diaphragm valve on a pulse jet bag house. 36. Tube sheet. The internal divider surface that separates dirty from clean gas plenums. Fabric filter bags are seated in the cell plate. 37. Venturi. A cone-shaped device located in the top of a pulse jet bag to help concentrate the high-pressure cleaning air jet. 38. Weight. Fabric filter bags are selected based on an average weight per square foot. 1. BH equals bag house. 2. PJ equals pulse jet bag house. 3. RA equals reverse air bag house. Maintenance. Preventive maintenance, survey. 1. Lubrication. 2. Cleaning. 3. Inspection and adjustment. 4. Checking of condition. 5. Replacement, include lubricants. 6. Performance test. Cleaning. 1. Filter. Carry out general cleaning on and around the filter. 2. Clean air module. The clean air module must be cleaned on the inside when replacing the filter bags, or cleaning must be carried out at least 4 times a year. Inspection and adjustment. 1. Compressed air connection. Check that all joints in the pneumatic system are tight. 2. Filter housing. Check that all doors and joints are tight. If necessary, replace the rubber seals of the doors. Leaks, if any in the filter housing, must be sealed by means of joint filler. 3. Solenoid valves, membrane valves. Check that the valves function properly, replace defective membranes and solenoids. 4. The membranes can be replaced by dismantling the valve housing. The solenoid can be replaced by removing the lock washer at the top of the solenoid, and the electrical connection, on the side of the solenoid. Checking of condition. 1. Filter bags. Check for signs of visible dust in the air stream which leaves the filter stack. If visible dust is observed, this means that a filter bag is defective. The door above the defective bag will be visibly affected by the heavy dust exposure. Replace the defective filter bag. Check that the new filter bag and the other bags are correctly attached to perforated plate. 2. Filter housing. Check that all doors and joints are tight. Replace the rubber seals of the doors if necessary. Leaks, if any in the filter walls, must be sealed by means of joint filler. Replacement. 1. Compressed air control valve. Replace the filter cartridge in the compressed air filter. Performance test. Filter control units. Filter control units, and check that the controllers function properly. Measure the differential pressure, and check that the differential pressure measurement of the controller is correct, and that the controller starts the cleanup operation at the foreseen pressure. Check that all outputs function properly, and that all bag rows are cleaned. Faults and remedy. Fault 1. Increased pressure loss across the filter. Cause 1. Excessive air volume to filter. Remedy. 1. Measure the air volume, if necessary use a pitot tube. 2. Set the air volume for correct value. 3. Check that the baffle plates are correctly fitted. 4. If necessary, weigh out the amount of dust which leaves the filter through the air sluices, and check that it does not in any significant way exceed the anticipated volume. Cause 2. False air at the bottom outlet of filter. Remedy. 1. Check whether the air sluice is tight. 2. Replace the impeller if the sluice is not tight. Cause 3. Faulty electronic control unit. Remedy. Locate the fault and replace defective parts. Cause 4. Malfunctioning of solenoid valves and membrane valve. Remedy. Check the function of valve. Cause 5. The membrane valves are stuck due to water content in the compressed air. Remedy. An improvement of the compressed air quality is needed to ensure that the dew point of the air is below that of the ambient temperature. Fault 2. Visible dust escape in airflow leaving the stack. Cause 1. Damaged filter bags. Remedy. 1. Replace defective bags. 2. Identify the defective bag by closing the dampers in the clean air modules until the module in which the defective bag is fitted has been localized. 3. Above the defective bag, the large cover will typically be visibly affected by the dust load. 4. Replace the defective bag and check that the new bag and the other bags are correctly fastened. Cause 2. Leakage between filter chamber and clean air chamber. Remedy. 1. Check the joints between the filter compartment and the clean air compartment, and make sure that leaks, if any, are tightened. 2. Check that the collars of the filter bags provide satisfactory sealing between the venturi nozzles and the perforated plate. Fault 3. Inadequate air volume through filter. Cause 1. Too low fan pressure. Remedy. 1. Check the speed of fans. If relevant. 2. Check for slip page of the V-belts on the pulleys. 3. Adjust, or replace the V-belts. Cause 2. The pressure loss across the filter is too high. Remedy. Reduce the pressure loss by adjusting the differential pressure value, delta P control limit, in the filter control unit, primary control. Cause 3. There is no supply of compressed air to solenoid valves and membrane valves. Remedy. 1. Use the pressure control valve to check whether the compressed air filter is clogged. 2. Check whether the automatic water separator functions as intended. 3. Replace defective parts. If necessary, move the compressed air inlet indoors, where the temperature is above the freezing point. Bag filter troubleshooting. Faults and remedy. Problem. High delta P. Possible cause. 1. Bad gauge. Solution. Check gauge by blowing into it. If needle does not move, replace gauge. 2. Leaking gauge pipe. Repair leaking gauge pipe. 3. Choked gauge pipe. Clean or replace gauge pipe. 4. Low header pressure. Minimum required pressure is 6.3 kilograms per square centimeter, gram. Check supply pipe, drain valve for leaks. Check diaphragm and solenoid operation. 5. Static charge on filter. Solution. Static electricity will interfere with the cleaning operation, ground the filter. 6. Water in air line. Remove water and clean the system. Check regularly the manual or automatic drain valve of air filter. Replace the defective one. 7. Bag blinding or chalking. High moisture or condensation will cause dust cakes, which are difficult to remove. It blinds and chokes bags. 1. Preheat bag filter on startup, use space heater on for long shutdown. 2. Wash bags, use after drying. 3. Membrane bags, permanent sole. 8. Wet compressed air. Solution. Humid compressed air allows dust cake to stick to the bags. Ensure clean and dry compressed air. 9. Too high system airflow. Check for airflow figure. If it is very high, the AC ratio will also be very high, causing high delta P, as well as re-entrainment. 10. Dust particles too fine. Ask customer for actual particle size analysis, compare with figures given in the order. Excessive fines will simply choke the pores on bag surface. 11. Pulse pipe misalignment. Minimum required pressure is 6.3 kilograms per square centimeter, gram. Check supply pipe, drain valve for leaks. Check diaphragm and solenoid operation. 12. Bag and cage pinch, not okay. Solution. For normal felt bags, the bag and cage pinch should be within 6 mm to 12 mm. Replace 2 tight bags, as well as 2 loose bags. 13. Long pulse frequency. Adjust off time by observing bag filter delta P, and set reduce off time by 5 seconds interval, and watch till delta P stabilize. 14. Pulse on time. Pulse on time should typically in the range of 80 to 100 milliseconds. Some fine dust application, it may require higher on time, but that should be verified first. 15. Sequential controller problem. Solution. Any malfunction can cause irregular pulsing, causing raise in delta P, across bag filter. Repair or replace cards. 16. High dust load. If actual value is higher than design, check everything and then increase pulse frequency, till 10-second interval time. Else, advise customer to go for pre-filter. 17. Wrong bag installation. Look for dust on clean air plenum, blank or dummy the defective bags. 18. Bad gauge. Solution. Check gauge by blowing into it. If needle does not move, replace gauge. 19. Leaking or choked gauge pipe. Repair leaking gauge pipe. 20. Holes in bags. Replace worn bags. 21. Low system air volume. Check duct systems for deposits, closed dampers. It causes work area problem, for dedusting system. Problem. Emission. Possible cause. 1. Holes in bags, cut in snap bands. Solution. Replace damaged bags. 2. Pre-coating, seating not done for new bags. Carry out proper pre-coat seating. If not possible, wait for some time till the process stabilizes, after startup. 3. Wrongly installed dummies. Check all dummies, and ensure tight fit, else replace them. 4. Chemical attack. Check whether bags are being torn, just by hand pressure. If so, chemical attack is confirmed. Problem. Poor bag life. Possible cause. 1. Overcleaning. Solution. Increase pulse frequency, or off-time duration. 2. Abrasion. Poor inlet design causing high inlet velocity, and elbows at inlet can cause accelerated abrasion of bags. 3. Bent or corroded cages. Replace bent or corroded cages. 4. High air volumes. High AC ratio shortens bag life. 5. Moisture in compressed air. Solution. Moisture in compressed air might cause acid mist in some application, and weaken bags. Moisture also shrink some fabric materials. Take corrective action to control moisture. 6. Thermal shrinkage. Some fabrics like polyphenylene sulfide, Riton, is having thermal shrinkage. Overexposure of high temperature might cause such shrinkage. Setting of temperature alarm is important. Problem. Hopper plugging. Possible cause. 1. Cleaning malfunction. Solution. Check pulsing system as a whole, and take corrective action. 2. Dust disposal system, malfunction. Inform customer about malfunctioning, about rotary airlock valve, screw conveyors, and chain conveyors. 3. Wrong design of dust disposal system. Establish through data collection. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.